So we're going to start our functions unit today. We're looking at Module 5 on Khan Academy. And the first skill you see here, evaluate functions, is quite a basic introduction to it. What you've been used to so far is you've been used to looking at linear equations, and you've been used to looking at the idea of having an equation, say y equals, and I'll put in a slope, say 5x plus 3. Okay, and this is aside from this. This is not the same as what we're looking at here. So you've been looking at something like 5x plus 3, and you've gotten used to the idea, I hope, that your input value and your output value are given by this linear equation. So if you've got say a 3 right here as your y-intercept, and then we're going 1, 2, 3, 4, 5, and across 1, and then we've got our output right here as well. So we've actually got our line. This is our 5x plus 3 line, and what we're looking at here is that the input, say 1. Say our input 1 for x, so if x equals 1, then we know that y is going to be equal to 8. Then our output y is equal to 8. And what we know from our equation is that, okay, well, if I was to plug in, say, 1 for x, and if I was to solve that, then my y value is going to be 8. So we've kind of gotten used to the idea of this being an input and this being a dependent output. Okay, so this is what we looked at with linear equations, and we really didn't have any way of specifying what the input value actually was, but we were talking in general terms that an equation builds a line, and that you can choose any input you like for x, and when you do, it will give you an output that is dependent on that input. So that's what we were looking at, and what we find when we look into functions, and just a disclaimer here, the 8th grade standard does not require you to learn function notation, and function notation is this kind of notation here, which we read as g of r. But though the 8th grade standards don't require that of you, I strongly recommend it because it does make functions make a little bit more sense. So the idea being here that the r is your input that we looked at before. So there's your r as your input, and what we're saying is that as you looked at this would be kind of like your y, and what we're saying is that instead of saying, well, we're not going to use a letter for the output, instead we're going to say that the function performed on the input r. So we're saying this is something that's completely dependent on the input, is what we're saying. And when we say it like this, we now have the luxury of asking the question, well, what is the value of the output if our input is 6? So that's why why this function notation is so especially useful, because we can actually specify our input within that notation and still have it uniform, giving us our output. So we're talking about g of r is your output, g of r is the output, and we've got, in this case, r is your input. And what you will notice a lot is that, like your traditional equation where you had x and y, typically you will see x is your output and f of x is your input. Sorry, the other way around. X is your input, I'm sorry, and f of x is your output. Okay, and what you'll see in some text, you'll see that they'll tell you that f of x is the same as saying y. So what we're saying here is that this g of r is the equivalent to your y when you're looking at them in terms of x and y, and the r is the equivalent to your x. Okay, now it's quite easy to solve these because all you actually have to do is take the equation you've been given, Right? Take the expression you've been given and plug in the input value where it belongs. So that 6 is, we're saying that this 6 is the R. So we're going to plug that right in there. So we're going to say G of 6 is equal to -1 minus 7 times 6. So this 6 here is specifically our input value, right? Okay. If we were to plug in, if we had G of 5, we'd be plugging in 5, and so on, right? So that's actually quite easy to solve because we know that -7 times 6 is -42, and -1 minus 42 is equal to -43. So we know that G of 6 is -43. Let's take a look at another one. And once again, we're looking at G of R and R. Again, we're saying that this 4 here is our input that we want to choose to plug in for R. Okay, so we're going to rewrite this equation. We're going to say that G of R, which is our output value, is equal to 25 minus 3 times 4. Sorry, we should have put a 4 here as well. 3 times 4, and there we have it, right? Okay, where the idea being that where G of R is equal to 25 minus 3R, G of 4 is equal to 25 minus 3 times 4. Same as if G of 6 would be equal to 25 minus 3 times 6. So again, quite easy to solve this. This is just giving us 25 minus 12, and that gives us 13. Okay, so G of 4 equals 13. So the idea being just plug in the value into the expression. Plug it right in. You're given it, so plug it in and solve from there. Okay, let's see how you do on your own.